This is my example of how to do one of our homework questions. You also get practice on your labs, which I think is maybe a little bit more realistic, but this gives you some extra practice. So I'm told that the average American gets a haircut every 36 days. And the question someone asked me is this going to be larger for college students? i.e., are they going to wait for a longer amount of time? So I go out and I collect a sample. But maybe, right, we should have done this after we've decided things. So first I'm going to do my research question. The research question is the average number of days for college students larger than 36? My null hypothesis is probably going to be, no, it's not. It's exactly equal to 36. However, my alternative hypothesis is going to depend on whether I want a two-tailed or a one-tailed, and the information is contained in the question. It says, is the average larger? Which means I'm going to go for the right-tailed hypothesis test. Oh yeah, we're always going to use a t-test because all of these are about population means. We're not covering proportions for hypothesis tests in this class. So it's going to be a right-tailed. So I'm going to pick, I think that the average is bigger than 36. Now it asks for some information. It needs a t-test statistic and a p-value, and it wants you to compare the p-value to the significance level, which here is going to be pretty stringent. So here's how I'm going to suggest you do it. Copy your data, highlight it, Control-C or Command-C if you're on a Mac. Go into your RStudio. If you want, you can open up a new blank script so you don't overwrite any of your other work. And we're going to do something like data equals, the letter C is how you put in a vector of data, which you may have noticed from other places. And if I run this, there's my data, all right there. We're going to talk in a few minutes more in depth about how to pull the pieces out, but it's really easy to do a hypothesis test in R. You just type t-test and you give it your data and you tell it what you think that population mean is going to be. So you use mu and mu for mu, and we think it's going to be 36. And since we're doing a right-sided, you do alternative equals greater. Let me just show you how it would be if it were left-tailed. The only thing that's different is for alternative, you write less. And for two-tailed, the only thing that's different is that you write two-sided. And those are here. All right, once you have this code, you've given your data a name. I called it data. You run the code, and it gives you an output that's going to let you answer basically the rest of the question. So the test statistic, it's going to be T because we're using a t-test. It's right there, T. So in this case, 0.612. I'm going to just copy that in there. The p-value, haha, right there. Now you might have to do some rounding. This is 4 digits. This one's 3, so I'm going to have to round up to 0.437. That's where you get your information. I know we're recording, so you don't have to talk, but let me see a show of hands if this is a surprising result. 0.437 as a probability. I don't see any hands because that's not a very small p-value, right? It could happen 43% of the time that this sample would occur, even when the average haircut for college students is 36 days. So that's not surprising. there's no evidence that this is not representative. The p-value, which is 0.437, is much bigger than the significance level, which was 0.01. And so there it is, failed to reject, right? And then the tricky option is accept the null hypothesis. In statistics, we don't say we accept it. We just say we fail to reject it. Because, let's see. The data suggests, I don't know which one is right yet. I have to read all three carefully. The data suggests the population mean number of days between haircuts for college students is not significantly higher. Okay, I agree with that, than 36. So there is insufficient evidence. Yeah, right, not enough evidence to conclude that it is higher. This one I don't agree because it says it is significantly higher, but we said it wasn't. And this one I don't agree because if it's not significantly higher, then to say there is sufficient evidence makes no sense. And then you submit. What didn't it like? I accidentally clicked on them. Interesting. This question is wrong. I'm sorry, I'm gonna have to wipe that off.
No, it's right. You just have to click the little.
Oh, okay. I clicked. Oh, I see. Thank you. And there we go. You all are better at homework than I am. Okay. All right. So that's how you do it. One quick recap. Take your data, copy it, put it into R. Make sure there are commas between each of the numbers, which fortunately for you, there are in the homework, but you also have to add the C and the parentheses on either side. And once you do that, you just get to run the t-test, which gives you the t-statistic and the p-value, which then can go in and then you draw your conclusions.